Methods of calculating accrued depreciation. Accrued depreciation is the total depreciation which has already occurred up to the date of value. On the flip side, remainder depreciation is depreciation which will occur in the future or essentially after the date of value. When we look at accrued depreciation, it can be classified in two ways, either curable or incurable. The measure to differentiate between curable and incurable is economic. It's physically possible to restore most depreciation, for example, by completing an expensive restoration. However, in most cases, the economic gain is compared with the cost of curing the depreciation. It will then be deemed incurable should the costs of restoration exceed the cost of replacing the entire improvement. The most common strategy for calculating depreciation is the straight line method, sometimes referred to as the age-life method. Using this method, the depreciation recurs annually and proportionally to the improvement's total estimated life. For example, an improvement that has an estimated total life of 50 years would depreciate a consistent 2% per year. I got 2% by taking 100% and dividing it by 50 years, meaning I would need to depreciate 2% a year. A common term is effective age of an improvement. Effective ages are used more frequently than actual age. Effective age is defined as the age of a similar improvement of equal usefulness, condition, and future life expectancy. For example, if an improvement is 30 years old, but it's been impeccably maintained, it may sell for the same price as nearby properties which are only 20 years old. So in this case, due to the maintenance, the effective age of the improvement is only 20 years. Appraisers don't get off that easy, and they can't use straight line methods to calculate depreciation, and neither should brokers. That's because buildings in reality don't depreciate exactly the same amount every year, because they're going to depreciate more in some years versus others. It's going to depend on the maintenance done, as well as the demand for that particular type of improvement. Let's complete a very quick example using effective age. If a house has an actual age of 25 years and an overall estimated useful life of 50, we would depreciate 2% per year. For accounting purposes, if it was straight line method, total depreciation would currently amount to 50% of the original cost of the improvement. But since we're not accountants, we need to consider effective age. After looking around, similar improvements are only 20 years old, which would place our improvement at an effective age of 20 years. Accrued depreciation would therefore be 20 years times 2% for a total of 40%. Let's place our work in a table just for easier understanding. The cost new for this example, we will say, is $1.2 million. This is for the improvement only, and we will need to account for the land in a moment. Our accrued depreciation based upon the effective age is 40% times 1.2 million, which is 480,000. We then subtract the accrued depreciation from the calculated cost new to reach a total depreciated value of the improvement of $720,000. We still have to add in the land value, which for this particular property is $500,000. This leaves us with an indicated value using the cost approach of $1,220,000. When we measure physical deterioration of an improvement, not every element of the property is in the same condition. As a result, adjustments need to be made. If a building has a useful remaining life of 30 years and an effective and actual age of 20, we can take a look at an example of how we might deal with some differences in specific elements degrading faster than others. In this example, the reproduction cost for the structure itself is $2.3 million. The roof is currently 75% deteriorated, and a new one would cost $100,000. Air conditioning and heating systems are 50% through their useful life. The installed cost new is $50,000. Let's attempt to calculate the total amount of physical deterioration. The building itself, under the straight line method, is 40% depreciated because its actual age matches its effective age, and we have a useful life of 50 years. Just like the previous example, it would be 100% divided by 50, which leaves us with the 2% depreciation annually. When we go through these calculations, it's important to note that the lifespan of different elements of the structure differ. Our roof, for example, has a shorter life than the rest of the building. If we calculate the depreciation to the roof first, we go about it by multiplying 0.75 by 100,000. This is the equivalent of 75% of $100,000. The total depreciation, therefore, is $75,000. For the air conditioning and heating units, we perform a similar calculation, 50% multiplied by $50,000, resulting in $25,000 of depreciation for the equipment. We can't forget the rest of the building, which is valued at $2,150,000. We reach this figure by reducing our reproduction cost by the replacement cost of the roof and the air conditioning and heating units. We do this because we can't double count the HVAC and the roof, and therefore we need to remove them when calculating the remaining deterioration. We then multiply 40% by $2.15 million for a total depreciation on the rest of the building of $860,000. All that's left is to add them all up and reach a total physical deterioration of $960,000.